We had seen how the losses were calculated, and then we do backpropagation to minimize those losses. At every time step, we compare the predicted label with the actual label, because this is supervised learning. So we have the labels for each data. Okay, this is how we do machine translation in the case of encoder and decoder blocks. Here, all these blocks are LSTMs, as we considered this in the beginning. Now we are going to look at few interesting features that improve the performance of encoder and decoder. One is teacher forcing. I'm going to show how this is done in the decoder block. Okay, this was the first time step. HT and CT are passed into it along with start of sentence token. Okay, let's say this produces an output. Let's write it here. Let it be y1 cap. Y1 cap has these as our output vectors, right? We took 6 as the dimension of these vectors, right, in the output language. So this is how it looks like. And the actual label would be this. The first word was मैं. So this is the vector representation for that. Now if you observe carefully, one thing I wanted to add was, when these outputs are generated, output vector is generated, we pass it through a softmax layer, which brings all values, which normalizes all values. Okay, if you observe carefully, then 0.5 is the highest value. Okay, this would mean that it is pointing at this vector. If you see, then it's generating say instead of मैं in the first time step. It is generating say. Okay, let's write its full representation. This is how say would look like if you go by one hot encoding here. So it is generating say instead of मैं. Okay. So instead of producing the actual prediction that we made, what we do is we give the embeddings of the correct output into it. So we give the vector representation of मैं into it instead of giving the wrong one say. Okay, so that the model is not confused, and we are doing training, right? So even if the predicted label is incorrect at any time step, it should not disrupt future words. Okay, in this way it saves time to train the entire model. Okay, this actually saves time. Or else, if we pass on the wrong predicted value instead of the correct one, then the parameters would take more time to settle in and correct this. Eventually it will get corrected, but this just increases the speed of the entire training process.